All right, so let's say we want to get like some idea of how long it takes like fourth graders to kind of get through like multiplication problems. Okay, so let's say we get fourth grader, we get Billy, and we get Sarah. So they're all fourth graders. And we have Max, Steve, and Jessica. Okay, and what we do is we give them like this test. It's like a video game kind of, and we see like, all right, at 3 seconds, or like at different time intervals, like how many correct they have. So for example, Billy at 3 seconds, he already has, well, he has one correct, and then at like 6 seconds, he has three correct, and then at 10 seconds, he has a total of five correct, and I'll do one more, and like at 15 seconds, he has nine correct. Do you understand what's going on? Okay. And Sarah, at 3 seconds, let's say she has two. And then, and I messed up on the stopwatch, by the way, and it's at 7 seconds. And she's at 5. And then at 11 seconds, she's at 7. And then at 16 seconds, she's at 12. And then Max. So Max, we have 3, 1, 6, 4, 10, 6, 16. And then he like got really fast all of a sudden. Okay. I don't want to do the others. I think we'll get the gist of it with just those guys. So Billy, Sarah, and Max. You with me? Okay. So we have to put something on this axis, on the x-axis, and we have to label the y-axis. What do you think we're going to label the x-axis? So think about like which one depends on what? Like which one is like not, you have no control over really? Do you have no control over time, or do you have no control over answers? You have no control over time. So the answers depend on the time. So the one that's independent that can stand on its own goes on the x. And also, by the way, like if you ever see time, 99, like most of the time, 99% of the time is x. All right, and this is number correct. Okay, so I'll try to spread this out a little bit. So this will be, no, definitely, no, I'll leave it like this, I guess. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I changed my mind. I'm spreading it out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. So the highest one we have is 12. Oh wait, I'm looking at the wrong thing. It should have been 16 because it's time. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 13, 14, 15, 16. Okay, so that's the time. That's from right here, right? Okay. So what am I going to go up to on this side here? 12. Okay, so 1, 2. I don't know if I'll make it. I'll do the, oh, I'm not going to risk it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we're going to plot Billy's and stuff. So how do I plot this one? Just for Billy. Make a dot. All right. So we'll say Billy is red. Well, I'm going to get fancy here. All right. There's Billy. Okay. So we got 3, 1, 6, 3, 6, 1, 2, 3, 10, 5, 10, and then 1, 2, 3, 4, 5. And what's the last one for Billy? Okay, 15 and 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's Billy. Sarah, we'll keep Sarah blue. So what do I plot for Sarah? 3 and 2. All right, so 3, 1, 2, and then 7, 5, 7, 1, 2, 3, 4, 5, and then 11, 7, 11, 1, 2, 3, 4, 5, 6, 7, and 16 and 12. 16 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and Max will be green. And Max we have 3, 1, which is the same as Billy. And then 6, 4, 6, and then 1, 2, 3, 4. And then 10, 6, 10, 1, 2, 3, 4, 5, 6. And then 16, 12. 16 and then 1, I think this one was 12. Yeah. Okay. So what are all these different colored dots? Yeah, the points of each person. Does this dot, I'll make it like a weird color that stands out. Does this point right here exist in any of our data values? No. But what grade are these kids in? 4th grade. Let's say I want to predict. Let's say I just have a question like, what is the average? What is the average number correct for 4th graders? For 4th graders in 8 seconds. Do I have like a dot at 8 seconds? No, right? And even if I did, that doesn't mean like, does that mean like, let's say it was for 6 seconds. Should I just use like the green number? Or the red number? Why not? Yeah. Say that again? What if I say like, all right, if I was asking like, hey, what's the average like of all children in the United States in 6 seconds? And should I be like, hey, all children can do 3 correct in 6 seconds? Why not? I don't know that. I only know that Billy can do that, right? And in fact, Max got more correct. So what you do is you do what's called a line of best fit. The line of best fit is a line that's calculated through your calculator can do it. Okay, so what it'll do is you don't have to calculate the line of best fit. You have to know how to understand the line of best fit. So you're gonna get this line by plugging in all these data points, and it's gonna try the best it can to connect these lines. Like it's gonna go like right between all of them, like as much as it can. And it's gonna have like the same above it as below it. So something like that. Okay. And with the line of best fit, you might be given an equation. Okay, so the equation, and let's pretend like you're not given the equation, but sometimes you are. So if you're not given the equation, you go right here and you say, all right, well, it crosses the grid right here, and it crosses the grid right here. These 2 points, here and here. So what is the first point? 8, 5, okay? So 8, 5. So 11.5 and 8, okay. Do you know how to find the equation of a line if the line goes through 2 points? Okay, how do you find the slope? Which is m. How do you find the slope of this line? Y2 minus y1 over what? X2 minus x1. Okay, and what is that slope? Or what do I write down? 8 minus 5 over what? Yeah, 11.5 minus 8. All right, so let's punch that out. So 8 over 5 or 8 minus 5. So that's 3. Oh, wait, or 3 over, and then I'm going to put the bottom part in parentheses so nothing messes up. And I'll go 11.5 minus 8. Tell me what you get. Okay, and keep on going. Yeah, so 0.857. So 0.857. Okay, so from there what you can do is just write down y equals mx plus b. Okay, and we know this number for sure, by the way. What is that value? What is m? Yeah, so 0.857. That's our m. And for y, just pick an actual y that exists on this line. I know an actual y that exists on this line. This one. That's an x, but this one. The other y that exists on this line is this one. Or anywhere that it crosses the corner of the graph. Okay, so go ahead and plug in your 5 right here. And then you got to plug in the corresponding x on the other side. So what do we plug in for x? Good, 8, okay. And then we write plus b. So our goal right now is just to find b. Okay, so now we have 5 equals 0.857, so 0.857 times 8, 6.856. 6.856 plus b. Okay, so how do I get b by itself? A minus 6.856 minus 6.856. So 5 minus 6.856. So 5 minus. What did you get? Yeah. So now you put it all together again. So now you have b is equal to negative 1.856. And what was our m? 0.857. So now we can actually write down the equation of this line. Do you know what it is? All you do is you write down y equals mx plus b, and you leave y as y and x as x. All right, so what's the equation? Minus 1.856. Okay. So, and on the test, more often than not, they're gonna give you this equation, and it's gonna be weird. It's gonna have decimals like this, and that's why, because it's like it's calculated like this. Okay, but with this equation, you can make predictions now. You can find points that aren't any of these points, and say that like fourth graders will do that on average. Okay, so we can say that like on average, fourth graders score anywhere along here. So it's not actual data points, but we use it to make like predictions about something. All right. So for example, if I say, hey, what's the average that a fourth grader can get right in 9 seconds? How do I do that? I'm gonna write the problem down here. So I'll say, what is the fourth grade? Oh, well, actually, let's do it for 8 seconds since I already wrote that over here. Oops. So what you do is is time x or y? It's x. So guess what we're going to plug in for x? 8. Yeah. So you just go like this. You say, all right, well, y, which is the number correct, equals 0.857. Then we plug in the 8 minus 1.856. Okay. And when we do that, 0.857 times 8 minus, you get 5, which makes sense. So we find 5. You see how 5 is not, like Billy or Sarah or Max, we did not find that they did 5, because they got 5 correct in 8 seconds. That's just like a prediction based on all these data values. And the more, so I'll say so y equals 5. So the more points you have, the more accurate your predictions will be. And that's how you read scatter plots. Any questions on that? Okay, hold on a sec. Okay, so our goal is to find this equation in slope-intercept form. The trend line, which is the line of best fit. Okay, so what 2 points am I going to use? All right, so 0, 3, and 8, 8. Okay. What's the first step? Yeah, 8 minus 3 over 8. Perfect. So y2 minus y1 over x2 minus x1. So you have 8 minus 3 over 8 minus 0, which is what? Is that the same as 5 over 8, which is 7.625? Yeah. Wait, did you get, is it 0.625? Okay, 0.625. Okay, cool. Now what do we do? You first write down your generic equation, like your basic one. What is it? Yeah, y equals mx plus b. And there's something we can plug in right now. What can we plug in? M. So we can plug in 0.625. Now what do we do? Which point should we take? No, you got to take a point that exists on the line. Eh. What's that? All right. Can you use the other one? Just because they're different numbers. Use this one instead. All right, so what do we do? Use 0, 3. Okay, so b is equal to 3. So now you have your b. So we have our b is equal to 3. We also have our slope from before, which is 0.625. So now we can put the whole thing back together again. Don't forget the x. X, mx plus, and then plus 3. See, so now we can make predictions. We can make predictions about things that aren't any of those blue points. Any questions? Any more questions on this?